All right, listeners, get ready, because today we're taking a deep dive into the world of exoplanets.
Yeah, we're talking about those fascinating worlds orbiting stars far beyond our own little corner of the galaxy.
We're honing in on GJ 9827 a day.
GJ 9827 Phi is a planet that's really shaking up our understanding of water in the universe. How about that? Well, it all starts with this place astronomers call the Radius Valley.
The Radius Valley. Okay, now you have to elaborate. What is this valley and why does it matter?
Imagine you're a cosmic real estate agent, right? Got all these planets to categorize.
Okay, I'm picturing it. What's the cosmic housing market looking like these days?
Well, the small ones, those around Earth's size, they tend to be rocky, like Earth or Mars. Then you've got your big spenders, the gas giants like Jupiter, just lounging out there in the cosmic suburbs.
I'm with you so far. So where does this Radius Valley fit in?
It's like that weird in-between zone, you know, the size range where we hardly ever find planets. Astronomers are trying to figure out, is it that planets this size are just super rare, or does something happen to them? Do they shrink? Do they disappear? It's a real head-scratcher.
And that's where our friend GJ 9827d comes in. This is where things get interesting.
This planet, it's like the outlier, it's sitting right on the edge of this Radius Valley.
So it could hold the key to unlocking this whole mystery. It's like a cosmic clue. So tell me, what makes GJ 9827d so unusual?
Okay, so picture this. A planet roughly twice the size of Earth, but way, way less dense. It's circling a star called GJ 9827, smaller, cooler than our sun.
Okay. Twice the size, but less dense. It must be pretty different from our planet. What else is going on with this mysterious world?
So, astronomers, they use the James Webb Space Telescope, and they managed to get a glimpse, and I mean a tiny glimpse, of its atmosphere.
And what did they find? Don't leave me hanging.
They found water, which is always exciting. But here's the real kicker. GJ 9827d isn't just another water world. Just picture a planet where the atmosphere is, well, it's insanely hot and so full of water vapor that it's constantly in what we call a supercritical state. Imagine water so hot and under so much pressure that it's not quite a gas and not quite a liquid. Think of it as a thick, soupy fog that's constantly churning. Astronomers are looking at a few different scenarios. One theory is that GJ 9827d, it formed way out in the icy boonies of its solar system, and it was chock full of water ice. But then, over billions of years, something happened. It started to drift closer and closer to its star.
Getting closer to that stellar hairdryer.
And as it got warmer, all that ice, it melted, it evaporated, and boom, super steamy atmosphere.
So it's like a cosmic sauna gone wild.
You could say that. But there's another theory. It suggests that GJ 9827 started out as a gas giant, kind of like a baby Jupiter. It would have had an atmosphere mostly made of hydrogen. But over time, all those lighter elements, like hydrogen, they may have just escaped, leaving behind the heavier stuff, like oxygen. And what happens when you combine oxygen and hydrogen?
High school chemistry, that's H2O.
Water. And not just a little bit of water, we're talking an atmosphere where water is basically the main ingredient.
So we've got a planet that's essentially one giant steamy sauna, and we're not even sure how it got that way. You know what I love about space? Just when you think you've got a handle on things?
It throws a curveball.
Exactly. And this planet, it's a curveball with a capital C. So we've got this cosmic sauna going on, and it's anyone's guess how it got so steamy. But, we were talking about that missing hydrogen before the break. It makes you wonder, where did all the hydrogen go?
Well, it probably didn't vanish into thin air, right? It's all about something we call escape velocity, is how fast something needs to be moving to break free from a planet's gravitational pull.
Okay, so bigger planet, stronger gravity, harder to escape. Makes sense to me.
Right. And even though GJ 9027DO, it's only about twice the size of Earth, it's got this surprisingly strong gravitational pull because it's just so dense. So if it started out with a hydrogen-rich atmosphere like many planets do, that gravity might have acted like keeping all that hydrogen from escaping.
But wouldn't the heat from its star make it even easier for that hydrogen to escape?
That's where mass fractionation comes in. Basically, even with the heat, some hydrogen might escape over time. We're talking billions of years here, but it happens very, very slowly. And as that lighter hydrogen slowly leaks out, the heavier stuff, like oxygen, it starts to stick around.
So over a really, really long time, that could lead to a buildup of oxygen in the atmosphere, which, when combined with the remaining hydrogen, you basically have a recipe for water.
Exactly. And not just a little bit of water, but a whole lot of it. The fact that we're not seeing a ton of hydrogen escaping actually tells us that this process, it's probably been happening for a really, really long time, slowly transforming the planet's atmosphere into the steamy mystery we see today.
That is so cool. It's like a slow motion cosmic makeover. Speaking of dramatic transformations, you mentioned that astronomers noticed some pretty intense flaring coming from GJ 9827D's star. What's up with that?
Ah, yes. Those flares are pretty fascinating. It turns out that this star, GJ 9827, it's a bit more, how to put it, temperamental than our own sun.
Temperamental, meaning
Meaning it tends to throw a lot more flares, a lot more energetic outbursts, more often than our sun does.
oh, okay. So this planet is basically getting blasted with these flares. That can't be good for a planet's complexion.
Well, you might think that, right? That these flares would be destructive, but actually, they might be playing a helpful role in GJ 9827D's evolution.
Wait, what? How can something as powerful as a stellar flare be good for a planet?
It's all a matter of energy balance. See, flares, even though they're short-lived, they release a huge amount of energy. We're talking ultraviolet radiation.
And that radiation, it can actually cause chemical reactions in a planet's atmosphere.
Precisely. It can actually help break apart molecules in the atmosphere, freeing up elements like hydrogen and oxygen. So those flares, they could actually be replenishing the water vapor in GJ 9827D's atmosphere. And by studying GJ 9827D's SAR and its flares, we can actually learn more about stellar behavior in general, including our own sun. So it's all connected.
We've covered a lot, but there are still so many unanswered questions about this steamy little world. What mysteries are astronomers most eager to solve?
Well, the biggest question is still the origin of its water. We've discussed a few possibilities, but without more data, it's hard to say for sure how GJ 9827D got to be the way it is.
So the hunt for more clues, more chemical fingerprints in its atmosphere continues.
Oh, absolutely. Finding things like carbon dioxide, methane, those could be the missing pieces of the puzzle. It's like we're on a cosmic scavenger hunt.
I love a good cosmic scavenger hunt. What else are we hoping to learn about this planet?
We need to figure out if that hidden ocean, that reservoir of water beneath the surface, does it actually exist? And if so, how much water are we talking about? Could it play a role in the planet's evolution?
It sounds like we've got a lot more exploring to do. And, I think it's incredible that even if GJ 98227 isn't the kind of place where we'd want to spend our next vacation.
Unless you like saunas, right?
True. But even if it's not habitable, it still has so much to teach us.
It's a reminder that our definition of habitable might be too limited. This planet, for all its strangeness, could help us broaden our understanding of what life is and where it might exist.
A huge thank you to our expert for joining us today and for taking us on this incredible journey to GJ 9827DR. And to our listeners, thank you for joining us on this deep dive into the mysteries of the cosmos. We'll be back soon with another fascinating topic, so until then, keep looking up and never stop questioning.